Here we go. And back to this important message from our sponsors. The following Zoom meeting session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today, eventually, we're going to be covering section 8.3. But first of all, I have several questions that people emailed me in, so we'll deal with those first, and then we'll deal with any other questions you might have. So having said that, let's see here. This is the first one we're going to look at, and I'm going to show you it on the WebAssign. So here we have problem number 1. It says, find the domain of each function. Part A, g of x equals the absolute value of the quantity x minus 5. All right, so let's take a look at that. Can you see my screen that I scribble on here?
Yes.
Yes. Okay, so we've got g of x equals the absolute value of x minus 5. If we pick any real number and put it in the place of x inside, and then subtract 5, we would still get a real number, right? A real number minus 5 would be a real number. Okay. If we take the absolute value of a real number, we also get a either positive or 0 real number. So there's no way that we're going to get undefined in this situation. So the domain would be all real numbers. Now, on WebAssign, one of the answers said the set of all real numbers. I just want to get you used to interval notation. Interval notation, you would have parentheses, negative infinity to positive infinity, parentheses. All right, so that's the part A. Any questions on that? Okay, part B of the same problem, it says f of x equals the quantity 9 divided by the quantity x plus 1. Again, they want us to find the domain. Well, now we have a variable in the denominator. In fact, the entire denominator is x plus 1. If the entire denominator is 0, then we're in trouble because we're dividing by 0 and that's undefined. So we want to know when the denominator, x plus 1, will be equal to 0. So if we solve this equation, x plus 1 equals 0. If we subtract 1, we get x equals negative 1. So negative 1 is the number that would cause the denominator to be 0, which would cause the function to be undefined. So basically, we want everything but negative 1. So it would be the set of all real numbers except negative 1. All right, with that, any questions on that? Okay, now we're going to go on to another problem. Let's see here. Hang on. Oh, right, this is the same. This is still in WebAssign. Let me find this one. Okay, so number 13, it says a software company has found that on Mondays, the polynomial function, blah, 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 whatever, there, approximates the number of callers to its hotline at any one time. Here, T represents the time in hours since the hotline opened at 10 a.m. How many service technicians should be on duty on Mondays at noon if a company doesn't want any callers to the hotline waiting to be helped by a technician? Okay, so the hotline opens at 10 a.m. Okay, so this function C of T deals with time beginning at 10 a.m. Now, the question has to do with noon. So noon is how long after 10 a.m. It's 2 hours. So basically the time, the t value that we want to put in there is 2, standing for 2 hours. Okay, so now going back here, what I need to do is find c of 2. Okay, that's how, so in other words, to evaluate this function at time equals 2 hours, we want to put a 2 in for t. So c of 2 is going to equal negative 0.0625 times 2 to the 4th power plus 2 to the 3rd power minus 6 times 2 to the 2nd power plus 16 times 2. All right. Now, we can do this a piece at a time. We can take 2 to the 4th power and get 16, 2 to the 3rd power and get 8, etc. Or we can punch it all into our calculator at once. I'm going to do it all at once, and then if you have any questions, let me know. Okay, when I do that, so let's see here, I've got what? Negative 0.0625, and then I'm going to go parentheses 2, close parentheses, raised to the 4th power, plus parentheses 2, close parentheses, 3 or 2 cubed, minus 6 times parentheses 2 squared plus 16 times 2. When I do that, I get 15. So they would need 15 technicians. Now, does anybody want me to go through more specifically the calculations on the calculator? All right, then are we good to go on to the next problem? I'll take that as a yes. Okay, let's see, next up, we're going to look at number 9. So let's see, can you see again my white screen that I'm writing on?
Yes.
Okay, good. I just want to make sure that I'm not showing students' screens so people don't know who's asking the questions. And so let me get this question up here. And let's see. This is number 9. Okay. All right. So this is number 9 in WebAssign. It says, write an equation for a linear function whose graph has the given characteristics. It passes through the point 28, 0, and it's perpendicular to the graph of g of x equals 4x plus 2. Okay. So first of all, it's perpendicular to the graph of g of x equals 4x plus 2. Well, that function, g of x equals 4x plus 2, is in slope-intercept form, y equals mx plus b. So the slope is 4. So the slope of that g of x function is 4. But we want the equation of the line that's perpendicular to that. Well, we learned yesterday, or reviewed yesterday, that perpendicular lines have slopes that are negative reciprocals. So the slope of the line that's perpendicular would be negative 1/4. So if the original slope is 4 and the two lines are perpendicular, the new slope would be its negative reciprocal. Are we okay with that? Any questions there? All right, so now I'm going to use this information, the new slope and that point. Well, if y equals mx plus b, and the slope is negative 1/4, I have y equals negative 1/4 x plus b. Okay. Now, I want to insert the point 28, 0. X is 28, so that goes here. y is 0, so that goes there. That gives me 0 equals -1/4 times 28 plus b. Again, any questions there? All right. -1/4 times 28 reduces down to -7. So 0 equals -7 plus b. If I add 7 to both sides, I get 7 equals b. So now I have my new slope and my y-intercept for the new function. So I've got y equals -1/4 x plus 7. But to write it as a function, I'm going to write f of x equals -1/4 x plus 7. So there is the final answer for that problem. Any questions on that? Okay, we're going to go to a new problem. Let's see here. This is, let's see, 8.2. Number 12. And okay, so now let's take a look at problem number 12. It says the volume V of R of a gasoline storage tank in cubic feet is given by that polynomial function, where R is the radius in feet of the cylindrical part of the tank. What is the capacity of the tank shown if its radius is 3 feet? So basically, we want to take that function, and R is going to equal 3 feet. Or in function notation, we want to find V of 3. Any questions about that? So now we're going to take 4.2 times 3 cubed plus 37.2 times 3 squared. And putting all of that into the calculator, 4.2 times 3 cubed plus 37.7 times 3 squared. And I'm getting 452.7. And that is cubic feet. So V of 3 equals 452.7 cubic feet because it's 3-dimensional. Are we okay with that one? Any questions there? Okay. Let's see here. We're going to go back to the WebAssign screen. This problem number 13, 2 different people asked for it, and I looked at it, and it's the same numbers. So this is basically the same problem that we did earlier. So with that in mind, I'm going to go on to problem number 14. A rectangular sheet of metal will be used to make a rain gutter by bending up its sides as shown below. If the ends are covered, the capacity f of x of the gutter is a polynomial function, and that one is given there. Okay. Find the capacity of the gutter if x is 4 inches. So basically what we're going to do is we're going to take that function and we're going to find f of 4. So we're going to have -240 times 4 squared plus 1440 times 4. Again, doing the calculation, -240 times 4 squared plus 1440 times 4, and I'm getting 1,920, and that would be cubic inches. Sad looking inches there.
Excuse me, Mr. Mayo?
Sorry?
I thought, well, if x is equivalent to 4 to the 4th power, right?
No, just, oh, that's inches right here.
Oh,
4 inches.
oh, I see. I thought
Yeah.
that was a 4 for a second.
Yeah,
Okay.
I see what you're saying there. Yeah, let's see if I can actually write it legibly. 4.
No, that's fine.
Here we go. Yeah, 4 inches. Good. Okay, that takes care of the specific questions that I was emailed. So now, are there other questions that you'd like to look at, anyone? Okay, in that case, we're going to go on to section 8.3. And for that, I'm going to switch screens. So we're going to get rid of that and go to this screen. Any day now. Okay. And let's see. I want to open up this one. Okay. So now can you see a graph screen with a graph on it, et cetera, et cetera? Just somebody say yes?
Yeah.
Okay. Just want to make sure, because every once in a while I don't push the right buttons and everybody's like, what is he doing? Okay. Actually, I ask that myself out all the time. Okay. So now the references I have here where it says number 17, that's just for my own sake. This is problem 17 on page 639 in the textbook, but you don't need to know that. But it says refer to the given graph to find each value. So I have this linear function here. This little f is just to say that we're referring to function f, okay? Part A, it says find f of -2. Now, what that means is, keep in mind that inside, that's the x value, -2. They want to know what the y value is on the graph when x is -2. So basically, they're asking us to complete that ordered pair. Well, if we look at the graph where x is -2, let me switch colors here. If we look at the graph where x is -2, come down here, what is the corresponding y value there? So right there for that point.
-4.
Right. So f of -2 equals -4. So this is just a function notation way of saying, look at the graph of f, find the point where x is -2, tell us what the y value is. Okay? But all that just, it says, find f of -2. Any questions on that one? All right. Another problem, find f of 0. So again, I'm going to come over to the graph. Where x is 0, what is y?
Zero.
Right. So f of 0 equals 0. This graph goes through the origin. Any questions on that? All right, let's take a look at part C. It says find the value of x for which f of x equals 4. Now, what's another name for f of x?
Y.
Y. Excellent. So they want to know what value of x put into that function produces a y value of 4. So now let's look at the graph and find out when y is 4. Oh, right there. So when y is 4, what is x?
2.
Correct. So that's sort of like Jeopardy. The answer is 4. What's the question? The output is 4. What's the input? 2. Okay.
Can I take y as f of x, y, but f of 4, x equals 4 for 300, Alex?
Actually, this is what you would have. You would have f of 2 equals 4.
Ah, man, this is, yeah, my head's spinning from this.
Yeah. I'm sorry, but now you're in negative numbers, so you won't be allowed to participate in Final Jeopardy. But we do have some
Final
lovely
Jeopardy.
prizes for you, some used calculator batteries. You can pick those up on the way out. But seriously, how are you doing with this?
It makes sense. It's just complicated.
Well, I'm gonna say this. The process isn't complicated, it's getting used to the notation. In other words, if I say to you, look at this line, find a point that has a coordinate for y that's 4. Oh, there it is. Okay. What's the x value there? 2. That's not difficult, right?
Right, but I could see how once we start getting into fractions and
Well,
decimals and
But what I'm getting at is you've got to understand that when they're doing that, they're basically saying complete that ordered pair.
right.
But you've got to understand the notation for doing that, because from here on out, they're going to be using function notation a lot. Okay, let's see. We've got
Right.
one more. What's that?
Well, I was saying, it makes sense. It's just learning a new language. Like you just
Exactly,
said.
exactly. Learning a new way to say the same old thing.
Exactly.
All right. Part D says the value of x for which f of x equals -2. Okay, so what's another name for f of x?
Y.
Y.
Why?
So where on this graph is there a point that has a y value of -2? Right there. All right. Y is -2 right there. So what's x?
-2.
No.
-1.
There you go. Yeah. And I don't have it labeled, my scale. Just assume that each square is 1 unit. Okay. Are you all right with that?
Yep, still makes sense.
Okay, good. New scenario, new graph. I know, lovely looking graph, isn't it? Looks much better in the book. My apologies. Okay. This is function S. So part A says find S of -3. So on the graph, where is there an input of -3? Right about there, right? So if we go up here, what is the output?
-4.
Right here?
Oh, I see. 0?
No.
No,
What's
I
the,
have no
Negative
idea.
what is it?
-3.
No, that's the input. Okay. What are the coordinates of that point?
Negative 3.
-3, -3, right?
No.
Or -3, 3. Like
No.
Isn't it?
Did somebody say it?
2.
Yes. 2, right there. Isn't that y equals 2?
Okay.
All right. We good?
Yeah. Yeah.
All right.
This is this is getting tough.
Part B, S of 3 equals what?
It's 3? No, it's 2 again. Isn't it? No, that's 1. 2, 3, 4.
There you go. We're talking about that point right there, aren't we? The input is 3, the output is 4. Okay. Good to go?
So far so good.
All right. Find the values of x. So find the values of x for which s of x equals 0. Now, the instructions changed from a previous problem. It says find the values of x. So there's going to be more than one x value that has the same y value. What does y have to equal in this situation?
0.
So where on the graph are there points that have a y value of 0? Let me remind you from that list we looked at yesterday, to find an x-intercept, set y equal to 0. So what we're actually looking for are the x-intercepts.
It's going to be -1 and 1, right?
That's a good start.
And 2, 3, 4, 5. Positive 5.
By golly, I think you're catching on. Good. Everybody seeing that? All three of those points have a y value of 0. So s of x equals 0 there. So what are the x values? -1, 1, and 5. Okay. Now, part D, same idea. Oops. Find the values of x for which s of x equals 3.
Is it 2 and 4?
Yes, it is. You ever play charades? This means you've got it. Either that or my nose itches, but you're getting it. Okay.
That's been a long time since I played charades.
It's a great family game night on Zoom. You can do it with your family that are all over the place. Anyway. Okay, we all right with that one? New one, here we go. Problem number 19. We have a new graph. And this is the graph of g. Okay, so this is the graph of the function g. And they want to know what g of -2 equals. Are we going to have?
So positive 2?
Correct. It's this point right there. When x is -2, y is 2. All right. For a minute there, I thought we were going to have a waiting it out contest to see who could wait longer. All right. How about g of 0?
3
Look more closely.
or
I was
2?
going to say this
There you
is
go,
where
2.
you're, yep.
Right there. Okay. Now we want the value of x for which g of x equals 3.
This would be -1.
Yes, right there. Part D, the values of x for which g of x equals -1.
To be -4 to 3, no, 3, -3 and +1.
Good. Everybody needs to get Anthony's phone number. He seems to have this figured out. All right. Okay. Any questions on this? Okay. Next problem coming up. Number 20. And this is function h. Part A says find h of -3.
Would be
4,
neg-
+4.
4.
Sorry.
Positive. That's right.
There? Is that what you were both thinking? Hopefully. Roger, is that what you?
Yes.
Okay, Nancy. All right. It's 4. Okay. Part B says, let's see, what are we doing here?
I just
H.
forgotten if the upper left, I thought that was negative at first. So
Okay. Over here in this quadrant, x is negative, but y is positive. Over here, they're
Okay.
both positive. Here,
okay.
x is positive, y is negative, and here they're both negative. Okay?
Okay.
All right.
Okay,
so
thank you.
Yeah, h of 4.
Be +3.
Yes. Values of x for which h of x equals 1.
0. Oh.
Values.
Nope. Equals 1 is just that point, isn't it? Okay. Okay.
Isn't it
Yeah.
1
Yep.
also?
Yep.
Okay. So when x is 0, y is 1. When x is 2, y is 1. All right.
Okay.
So
Yep,
basically,
that makes sense.
here's what you, so if h of x equals 1, then what you've basically got is right here, that's h of x equals 1. So every point that's on that line would have a y value of 1. So x is 0, x is 2. Does that make sense?
Yeah, it was throwing me off because it's like a check. It's like a check mark.
What can I say? This is actually the graph of an absolute value. How fun is that? All right. The value of x for which h of x equals 0.
Okay, x is 1 right there.
Good job. Right there. Okay. Any questions before we go to the next example? Here we go. All right, let's see here. So now the question is, got to get this out of my way here, is what is the domain of this function and the range of this function? Okay, now, domain is the x values in the function, going from smallest to largest. So going across, can you see my cursor moving around on the screen there? The little x. Hello?
I can't see it.
I was
It's
gonna
not,
say on mine, it's hidden.
okay, okay. So let me just do this. The domain is going from left to right, okay? So the x values from negative infinity to positive infinity is what you consider. The range is going from negative to positive infinity in that way. The domain is the x values, the range is the y values. Or look at my hand on the screen. The domain goes from left to right, the range goes from bottom to top. Now, let's look at this graph. Notice there are arrows here. That means that this graph continues on, okay? And this graph continues on, all right? But as this graph continues on going up, it's also going over, right? So as it keeps going up and it keeps going over, it's going to go in that direction to negative infinity, isn't it? In terms of x.
Right, negative and then positive y for
And then
infinity.
here, as this goes up, it's going to go to positive infinity. So your domain would be all real numbers, or the set of all real numbers. Because again, as this thing goes up, it's going over. As this thing goes up, it's going over. So eventually that graph would go from negative to positive infinity in terms of x. But now look at y. Where does y start? What's that y value that I've got circled there, that lowest y value?
3.
3. So it's going to be, let's see, all real numbers greater than or equal to 3. Now, up here, all real numbers, you'd write negative infinity to infinity interval notation. How would you write this? It would be a bracket with a 3 and then infinity with parentheses. I believe at this point, WebAssign is going with a written statement and it's like a multiple choice, but here's how you would write it in interval notation. This author kind of goes back and forth between these two. So your domain, all real numbers, your range, everything greater than or equal to 3. So there's no y value that's less than 3. So no matter what you put in there as an input, your y values are always going to be 3 or larger. Does that make sense?
Yes.
Okay. Next example, domain and range. All right. Here again, this arrow implies that this thing continues to go down and over, you know, et cetera, kind of thing. So where does the domain start? Where do the x values start?
It'd start at 0.
Okay. How far to the right do the x values go?
To positive infinity.
Right. So the domain would be all real numbers greater than or equal to 0. And in interval notation, it would look like this: bracket 0, comma, infinity, parentheses. Okay. So here's your domain. What about the range? Where does the range start? What's the smallest? Go
0.
ahead, bud. Sorry.
0.
It actually ends at 0. Range, you'd start from negative infinity going up. And I understand what you're saying.
But
It looks like it starts at 0, but range, you're talking from negative to positive infinity in terms of y. So how far down does it go?
To negative infinity.
Right. So your range would be from negative infinity up to 0. See what I'm saying? So I understand why you said it starts at 0, but technically it actually ends at 0, because range, we're not talking left to right. We're talking from the lowest to the highest kind of thing.
That makes sense.
Yay. Okay. So the range would be all real numbers less than or equal to 0. Okay. All right. So domain goes from 0 to infinity. Range goes from negative infinity up to 0. Smallest to largest, smallest to largest. Okay, you good to go on to another example? All right, let's see. This one. Okay, 67. So find a, let's see, this is the function g. So we want to find g of 1.
This is going to be 2.
Correct. Right there.
I was really trying to let somebody else that time.
Good. That's a good answer. Good answer. Okay. Let's see. Let's find g of negative 4. Somebody else.
B0?
No. All right. Where does x equal negative 4? Right here. Oh, it does not. You know what? My bad. I'm sorry, Roger. You are correct. I was mistaken. I was counting wrong. Can't even see. I graphed a negative 3. My humble
that's-
apologies. You are correct. It's right there. Good job. Shame on me. Okay, that's all you need is for me to confuse you with my wrong stuff. Okay, we all right? You've recovered emotionally from the scars I've caused? I guess not. Okay, well, we'll send you $50 for a math therapy session. The values of x for which g of x equals 4. The values of x for which g of x equals 4. While you're thinking about it, I'm going to erase my mistakes here. So this is the government cover-up. No one will ever know that I made mistakes there because I'm getting rid of the evidence. Okay.
That's terrifying.
Isn't it though? Except it's all on tape. The whole world will be able to see it later. Oh, Mayo blew it again. All right.
Not if you edit it out.
That's true, but I'm too lazy. I'm too lazy to do that. All right. The values of x for which g of x equals 4. Again, what's another name for g of x?
Why?
Correct. So where on the graph does y equal 4?
is it
It's
negative 3 and 3?
right-
Oh, negative 2 and 2.
there you go. Good job. All right. So y equals 4 here and there. X is what? Negative 2 and positive 2. Good. Okay. And then let's see. We want the domain and the range. And here in the book, they put it in interval notation. So what's the domain? Keep in mind, this is going to keep going down and over. This is going to keep going down and over. So what X values are going to be covered by this graph as it continues?
It's just all real numbers.
Okay, so negative infinity to infinity. Careful, what's the range? So these values. What's the smallest range value?
Four? No, negative infinity.
There you go. What's the largest range value?
And then 4.
There you go. See, you had the right answer. I just asked the wrong question. It's my fault.
No, I was backwards.
I know. It's all right. Got to get used to it. Okay, so your range goes from negative infinity up to 4. All right. Good to go on. Let's see, 72. What are we supposed to do here? Oh, is this a function? Yes or no? Keep in mind, if it's a function, each X value goes to just one Y value. Tell you what. What-
Isn't it not a function?
Correct. It is not a function. And it says, find two ordered pairs where more than one value of Y corresponds to a single value of X. Look at right there. I've got 1, 2, and 1, -2. So those 2 points show that it's not a function. Okay with that? In fact, there's something called a vertical line test. If I can draw a vertical line through the graph and it cuts through the graph more than once, that means that that X value has 2 different Y values, and therefore it's not a function. How about this one? Is this a function?
No.
No. An example, there's your 2 ordered pairs, what? 3, -2, and 3, -6. So not a function, not a function. And again, it does not pass that vertical line test idea. How about this one? Is this a function? Now, the filled in circles mean that dot is included. The open circles means that that value is not included.
So then this is a function.
Yes, it is. What if I filled in that dot? Would it be a function?
Now it just lost its function.
It just lost its function. There you go. That's right. Okay. But as it is, yes, it is a function. Oh, I didn't point this out yesterday. Function starts with the word fun. Woohoo! But it ends with shun. We all know what it is to shun someone. So I don't know. Anyway, okay, let's see. I think, yes, that was all I've got. And so I'm going to stop the